Hey, this is Miss D, and for today we are going to show you how to solve problem number 16 using factor label method, otherwise known as dimensional analysis. Remember, when you're doing problems like this, you have to correctly identify the given and you have to correctly identify the unknown. Once you have done so, figure out what factors are available for you to use or you need to use to solve the whole problem. So let's get it started with number 16. And you have the problem on your screen, and you can just you can follow along. If 1 barrel of crude oil provides 6 million BTUs of energy, how many BTUs of energy will 1 liter of crude oil provide? I can clearly see here in the second part of the sentence, they're asking me for how many BTUs of energy. So I'm going to write here on my unknown, labeled as U, BTU of energy. And the given for me there is 1 liter of crude oil. So I will write here 1 liter and just the initial CO for crude oil. Continuing with the question, how many calories of energy will 1 gallon of crude oil provide? So it looks like I do have two problems there. So I'm going to draw a line to separate the second problem, and the given for that second problem is 1 gallon of crude oil. Again, CO initial for crude oil, and the unknown for me there is calories of energy. Okay, you might be asking, so what is that first part of the sentence is for? Now it looks like it's not a given, it's not really the unknown, but it looks like a factor that I could possibly use later on. So I'm going to put it on the side. I'm going to put an asterisk there for 1 barrel of crude oil. It says it provides 6 million BTUs of energy. So 6 million BTU of energy. So far, I have analyzed the problem and I identify the given and the unknown. So what's the second step? The second step for me is to write my beginning unit and my ending unit. And since I do have two possible problems here, I'm just going to continue drawing a line here. And in this case, I need the liter going to BTU. That is for my first problem. The second problem is from gallon to calories. Okay, so that's my second step. My third step is for me to write down all the possible factors that I will need to use. I'm going to focus now on problem number 1, and let's try to set aside problem 2. Okay? Question, what are the possible factors that this problem have given me that I could so far possibly consider later on? So it looks like I do have liter. 1 liter is equal to 0.264 gallons. Another possible unit I could use is, it looks like I have a conversion factor for gallons and barrel. So I will write here 42 gallons is equal to 1 barrel. And the next question is, what possible unit can lead me to BTU? I cannot use this unit again, or else I will go back to gallon. And there's no other possible conversion factors that's given for me over there. So I'll go back to the problem. And if you remember, in the problem they gave you a possible factor that as I said a while ago, you could possibly use. And we wrote it on the side. It says here 1 barrel is equal to 6 million BTU. And obviously there, barrel to BTU. So it looks like we are now ready with our factors. We are using 3 possible factors here: liter to gallon, gallon to barrel, and barrel to BTU. The fourth step is to set up everything, all your factors correctly. Remember, you can only cancel unit if the similar units are, one is in the numerator and one is in the denominator. So I'm going to switch this to webcam so you can see the whole setup here. Okay, let's begin with the given, which is 1 liter over 1 of crude oil, CO. Question is, which between the three can I use first to cancel the unit liter? Obviously, I'm going to use this one. So I'm going to put a check, and I'm going to put liter on the denominator because the other one is in the numerator. So I will put 1 liter is equal to 0.264 gallons. Cancel liter and continue with your next factor. How can I cancel gallon? That could be my possible unit, or factor I mean. So 42 gallons is equal to 1 barrel. Remember, you can always interchange the position of the factors because they're equal to each other. So you can place 42 gallons on top and 1 barrel at the bottom. But I decided to put it this way so that I can cancel the gallon unit, 1 in the numerator and 1 in the denominator. Multiply by, how can I cancel the barrel? So I use the second one now, and my third factor is this. 1 barrel is equal to 6 million BTU. I don't want to write all the zeros, so we're going to apply now our topic on scientific notation. So it's going to be 6.0 times 10 to the 6th power BTU. Cancel barrel, cancel barrel. Pause for a while and see, do you have the unit that you wanted to have? Which in this case is BTU. You've canceled everything except for BTU. So it looks like our setup is correct. That means you can now proceed to solving the problem. Okay, equals. Okay, this is another challenge in AP Environmental Math problems. It's you're not allowed to use calculators. So how can you solve problems like this? That is the reason why you need to be very familiar with scientific notation. So we're going to, before we solve the numbers here, we're going to convert them into scientific notation. So 0.264 becomes 2.64 times 10. You move the decimal point 1 place to the right. Therefore, you just made it smaller. So 10 to the negative 1. If you wanted to have a review on scientific notation, we have another video on this one. But for now, I'm just going to swing through the conversion of our numbers to scientific notation. And this is already set. Let's convert 4.42 gallon into scientific notation. So we have 4.2 times 10, move it to the left, so that becomes 1. We can now proceed. 2.64, we have canceled this one, 2.64 times 6, we are going to get 15.8 times 10 to the 5th power. How did we get 5th power? That's negative 1 plus 6 divided by 4.2 times 10 to the 1st power. Proceed to the division or double check again. If you look closely here, I'm going to bring it closer, it's 15.8. Scientific notation need to be expressed to a number that's a number between 1 and 10. So this will become 1.58 times 10 to the 6th power. Proceed now 1.58 divided by 4.2 is equal to 1.58. Let me use the calculator to double check what I have here. It's gonna be 1.58 divided by 4.2 equals 0.377 times 10. When you are dividing exponents, you have to subtract. So it's going to be to the 5th power. And again, you have to change this into the proper way of writing scientific notation. So it's going to be 3.77 times 10 to the 4th power, and use the unit BTU. So now we have the answer for the first part of the problem.